I'm Juan Pablo Lasso and I'm here with Juan Royo, and we're here to present our large-scale computing project, which is based on insurance policies. We decided to use a dataset on insurance policies with the variables age, gender, BMI, and charges. We thought that these variables were important to determine the charges of each policy regarding different aspects besides like gender, age, BMI, and to factor in what affects the total charge of the policy. First of all, for our analysis, we want to explore how these charges affect. So what we did first is get some average of all the variables, average age, minimum age, maximum age, average BMI, and all of this for all the variables. For later on, use this as reference to what we're trying to achieve. Here we got also some group analysis. We have the age groups. We decided to factor in 5 different age groups and get the average charges between those age groups. Here we got the comparison between the smokers and non-smokers of our dataset, which we thought were important since there had to be some correlation between smokers and the charges in the policy. Here, it's the difference between those two. And here we have the gender-wise average charges, which is basically the average charges per female or male. A bit on the histograms. Here we have the age distribution of our dataset. We can see it's mainly in this area where the age is mostly distributed. Some a bit more histograms that we got. We got the distribution of charges for smokers and the distribution charges for non-smokers, which we realized that was interesting, that there was not that big of a correlation in the smoking and the charges for the policy itself. This could be explained because smokers don't care that much about their health, and that's why they're being charged like this. Okay, so we applied random forest to determine the importance of our variables. Here we have our top 6 features. Using this random forest, we have that the important scores, the most important variables that affected were BMI, children, and sex. This being BMI, particularly the biggest one with a 0.44 importance level. So that's important to know after we're applying the machine learning processes.
Okay, so the aim of our project was to predict insurance charges and to show how different values such as gender, age, and BMI could affect the insurance charge. So for this, we developed different traditional machine learning models. The first one is the XGBoost regression model, which show a learning rate of 0.3, and regarding the different iterations between loss and equal loss, both were decreasing. Then, in order to improve the accuracy of the model, we use the auto machine learning regression model, which showed a lower value of the mean square errors, meaning that it's better in predicting the insurance charges values than the different traditional model methods. And then finally we developed a comparison between 2 of traditional models, which are the linear regression and the XGBoost. Here we can see that the second one presents a lower value of the mean square errors, meaning that it's better in predicting the insurance charges. So for our regression problem, this was the best model, meaning that this could be helpful in order to develop different strategies for insurance pricing.